Welcome to all of you to the Forever Learning Institute. Today's session is actually the last one in our artificial intelligence focus theme. And if you've missed any of the previous calls, we had 3 other sessions earlier this year. They've all been posted to YouTube, and we will be sharing those links with you in the follow-up emails so that you can get a chance to see those if you've missed them from before. So today we're doing one of our formats called Duets, which is an opportunity for several faculty members to talk in pairs about their area of interest at Duke. So today our moderator is Nita Farahany. She is the Robinson O. Everett Professor of Law and a Professor of Philosophy here at Duke. She's a leading scholar on ethical, legal, and social implications of emerging technologies, and also the founding director of the Science and Society Initiative here at Duke, which is one of my favorite places to listen to content here as a staff member. You will see her frequently on national television and radio shows commenting on the legal and ethical implications of technology. And she did her undergraduate degree at Dartmouth before doing 3 degrees at Duke, her master's, J.D. and Ph.D. So with that, I will turn it over to our excellent moderator today, Nita Farahany.
Thanks, Jen, and welcome everybody. It's a pleasure to be here with you today and to have an opportunity to talk about the important issues with respect to artificial intelligence capabilities, liabilities, and responsibilities. I know that many of you are repeat offenders, having seen the rest of the series, but I promise there's a lot new and fresh in this particular conversation. As you all know, artificial intelligence is absolutely everywhere and part of our everyday lives. From what movies are recommended to us from Netflix, what advertisements are targeted to us on social media, what decisions are recommended for our treatments in healthcare, to what choices are made in national security. Artificial intelligence is at once ubiquitous and increasingly influencing our everyday experience of being human. Today, I am joined by colleagues from across the sciences, business, law, ethics, bioinformatics, and medicine to discuss the myriad capabilities and implications that AI has for national security, for how we live our lives, and for our well-being and health. Along the way, we're going to explore some important questions about not only what artificial intelligence enables us to do, but also what risks it introduces into our lives, along with what questions about what happens when something goes wrong. Who's responsible for safeguarding society from the downside risk, and who's liable for the damages that may occur? As Jen mentioned, you're going to hear from a series of duets, of pairs. We're going to talk about different issues. I'll come on to introduce each of those pairs, and we'll keep track of your questions along the way, such that at the end of the paired conversations, we'll have an opportunity to have a discussion. And so please post your questions throughout. We may answer some of them. Some of our other panelists may answer them during the conversation, but if not, we'll try to get to all of your questions by the end. So with no further ado, let me start by introducing you to Jeffrey Kralik, who's a professor of electrical and computer engineering at the Pratt School of Engineering, and Jonathan Odom, who's a research engineer at the Georgia Tech Research Institute, as well as an alum of Duke. So let me ask them to turn on their video cameras to join us for the conversation and to take it away in a discussion about national security implications and defense implications of artificial intelligence.
Thanks, Nita, and thanks, Jen, for inviting us to participate in this event. Yeah, I'm coming to you from Stockholm, Sweden, you guys, and so that's probably the furthest and coldest place I could be in this group. But of course, I'm at Duke, and my experience with AI has been in twofold, I'd say, maybe threefold. First, while I was recently, but came back just before the pandemic, I was a program manager. I was on leave from Duke as a government service leave to the Defense Advanced Research Projects Agency, or DARPA as it's known. And there, I started a program called Aerial Dragnet, which I came up with the name. I thought it was cute, actually, but it turned out to be a very bad choice of names. It's a counter unmanned aerial system program in urban areas. That's counter drone system. And of course, you've probably all heard about the dangers and risks associated with drones, but the idea was to have basically other drones in the air looking down upon in urban areas to find and interdict other drones with malintent. And of course, that's a huge problem everywhere from airports to other events. You can think of the Super Bowl and everything else. But the choice of aerial dragnet, I quickly discovered the name really set off flags. The first one, I was one of the 2 program managers who was chosen to appear before an intelligence inspector general panel, which was quite an experience about what data I was collecting. So as you've probably learned from the other sessions, artificial intelligence is all about data. It's all data driven. So the first question you have to ask yourself when somebody confronts you with AI is, where is the data that's coming? Where is it coming from that drives the machine learning techniques? So in my case, they were very worried about a program called Aerial Dragnet. That sounds like you're going to fly stuff, drones over the city, collecting on all kinds of personally identifiable information and tracking people. And I assured them that this resolution of our cameras and radars and so forth was not going to do that. But they were very concerned. And in fact, I'd say the general theme I discovered, actually, that's the other case, just to finish that story, is that another case it was in New York City with the NYPD, who were very concerned about drones in the city. And the special agent in charge, which is the high up in New York, FBI, came to me and said, "Jeff, why did you call it aerial dragnet? We don't do dragnets." From some 60s TV show. I don't know where you got that name. We don't do dragnets. And so generally speaking, my experience in the federal government was that you may be surprised about this, but the government is much more strict about the use of data than private companies like Google, Facebook, and this Amazon and this Twitter and so forth. There are a lot of safeguards, and people are watching very carefully. I had a program since I've been back at Duke, which involved looking at human gait to do re-identification. Now, this you could argue is, personally PII. Well, before the government would let the contract, we were required, even though there were only about 4 or 5 students involved, to have everything on a secure network. Nothing could be released, and consent from everybody. So that's been my experience, but I'll pass it over to Jonathan to talk about how the data can be used. That's an example of how it can be collected, but here's Jonathan's got some experience with how it can be used.
Thanks, Jeff. So first, I do have to start with the fact that I'm not speaking on behalf of the United States government or any government agency. So I'm actually on loan in the federal government. So everything I say here is my own opinion. But Jeff, first I want to pass it over to you, a question, right? Did you do your annual required training for privacy? Was that a thing when you were up here? Did they make y'all go through that every year?
I think, yes, I had to do the review before I appeared before the Inspector General panel. I'll tell you, my management was very worried about a Duke professor appearing in front of this panel, because if I stepped out of line, I mean, I didn't have to, I wasn't but if it said that they were worried I'd say something and the whole place would be shut down. but yeah, I had to do that training.
Okay. Yeah, I mean, training is one of the big things that we have now to help protect, privacy concerns. But as Jeff just said, it matters a lot how you collect the data. But the second thing is what decisions you make with the data, right? So I've done a lot of work over the last couple of years where we made important decisions with data. And so first I want to start with the use case of like what you should not do with data. So in the early 2000s, they deployed a missile defense system in Iraq. It was called the Patriot system. And what the system did was it protected US bases when people fired missiles at it. And so basically it saw the missiles coming in and it shot an interceptor, which stopped the incoming missile. And it was very successful in previous deployments in the Middle East. And so they deployed it in a very advanced automated mode in the early 2000s. And unfortunately, in the initial case, it actually misidentified a friendly aircraft and then shot that aircraft down automatically in this automated engagement mode. And so there was a result of a total of 2 aircraft, friendly aircraft, were actually shot down, and the loss of 3 human lives. Right. And so that's like how you shouldn't use a fully automated system. And a lot of the policies and changes that have been made over the last 20 years have been a result of the U.S. seeing that in the deployment of defense systems. So what matters here is how we engage human beings in the process. And so it's kind of well recognized, I think, now that human beings need to be involved anytime there's a decision that significantly impacts another human life. And so the General Data Protection Rights, the GDPR in the UK, has a rule that says human beings have to be involved in any process that has a significant impact on a human's life in general. And if there's a fully automated system deployed, you have the ability to contest that. So there has to be some way of explaining it. So that means that explainable AI, how do you let a human being understand why a decision is being made, is actually critically important. And so one of the things that we looked at Georgia Tech was, how do we involve a human being in this decision process? So one of the things that we did was we built a search and rescue system where you had a robot that was going around trying to find humans potentially in a disaster zone or any other type of situation where you needed to quickly find and gather everyone very quickly. And what we found was that human beings operating these robots actually didn't search very efficiently. And so what we did is we trained the software to actually, in some cases, take control or prompt the human operator to go look in a new area. So it's like the opposite of automatically braking your car. We were actually telling the human operator, like, hey, you need to go to a new area because you're not moving very efficiently. And we showed that this type of software could really aid a novice user of the tool so they could search much more efficiently. And then, that way you can actually have these man-machine teams that really make the entire system better, more reliable, and more usable, but only if you actually include the human being in our decision process kind of in that system.
Yeah, it's interesting, Jonathan. I think, my feeling of with respect to AI is that if the machine can help. I mean, there's a lot of people looking at ways of how to team humans with machines to improve their decision making, but it feels like the machine AI is at a point where it can do very simple human tasks, but at scales that humans could not do, where it would be incredibly laborious. So I'm just wondering, I'm trying to think of a missile coming in at you is a pretty rare event. So in that case, that would be a situation where humans, could be pretty tuned to. I mean, they're pretty engaged. In fact, actually, I had to visit when I was in the government. We visited the Iron Dome in Israel, and their system for missile interception, and there's humans involved there for sure. Even though there's a lot of automation. But I'm just wondering, where's a defense application? Let's talk about, say, TSA screening. There's a situation which is incredibly laborious. I can imagine that TSA misses a lot of stuff that comes through. Would that be inappropriate? Where could AI help in that situation? Because there's a lot of
Yeah, so I mean, typically where we talk about trying to define the lines is where the decision being made, right? In other words, the decision to arrest an individual maybe not should be automated, but the decision to say a human needs to look in this area or this person needs to be, investigated is a pretty good example. But there are very clear U.S. laws about what data can be used in that type of situation and what can't be. And so, I mean, it's super important to think about this in 2 places. One, when you're developing the system, where do we need to insert the processes? How do we handle data collection? And then when you deploy a system, that might actually be a different decision process. So we really have to think about it in both cases.
Yeah,
Well,
thanks.
this has been a fascinating discussion, and I mean, we've just scratched the surface. There's so much more I know that we could talk about here, and I look forward to the questions that our fellow alums have for you that we will discuss in the Q&A. So thank you both for these insights. We turn now to our next conversation between Jolynn Dellinger, who is a fellow alum and also a senior lecturing fellow at Duke Law School, where she is a visiting professor at the Keenan Institute for Ethics, and Allison Cheney, who is an assistant professor in the Fuqua School of Business, for a fascinating look at recommender algorithms that seem to govern so much of our lives, as well as thinking about how pervasive technology is in our everyday lives and how that really influences our everyday experience of being. And so let me invite them both to turn on their cameras and join us for a conversation. Again, I encourage you to post your questions, which I will field to all of our panelists at the end of these conversations. And so Allison, Jolynn, I'm going to hand it over to you to take it away.
All right. Thank you, Nita. So I wanted to start off our discussion with the distinction between AI, or artificial intelligence, and machine learning, because I feel like we throw these terms around and we kind of treat them as interchangeable. In my mind, they are distinct, though. I think of ML, or machine learning, as like the brain behind artificial intelligence. It's, takes in the data, does a lot of statistics on a big computer, and then AI is the bigger package, where it's served up with different layers of interface. So for example, Siri and Alexa, you have these audio interfaces, you have robotics. So there are different ways of interfacing with machine learning. And so the whole package, I think of as AI, whereas machine learning, where I focus most of my research interest, is kind of the core brain of it. So, just building off of that, we'll kind of use them interchangeably. So I like to think of AI or machine learning being able to kind of help us with the problem of information overload. We have more news articles than we could ever read in our lives, sitting on the internet. We have, lots of books, lots of movies. How do we pick which ones of which content to consume? And so machine learning has the promise of helping us find the things that we really care about. And that's why it's so appealing. That's why so many firms use it in practices. They're like, well, we want to help our users find the products, find the news articles, find the movies that they want to watch. And that's, there are lots of ways that machine learning helps with that. It can help kind of narrow down the content. It can, pick individual things. So that's kind of the promise that we're building off of.
So hate to do good cop, bad cop,
Yeah.
and that's a great about the facilitation of decision making. But I do want to just highlight some ways that AI, as it's involved in our decision making, actually has the capacity to compromise our autonomy and some other important values. So I wanted to give you two rough categories of AI enabled or affected decision making. And the first one is AI that makes decisions about people or that affect people. So a lot of the focus in this area has been on automated decisions about us, like our ability to obtain government benefits or housing, for example, whether a neighborhood's likely to be more highly surveilled, or whether a family is likely to be more subject to abuse and neglect proceedings, whether a person gets out on bail or released on parole. Virginia Eubanks has done some amazing work in this area in her book, Automating Inequality. And these decisions have significant implications for justice, fairness, equity, discrimination. But I wanted to bring attention today also to another concerning aspect of AI and decision making, which is how use of AI algorithms, as Allison was explaining them, affect our ability to make autonomous decisions. So autonomous decision making kind of writ large, which is an aspect of privacy, and how we're able to make decisions that are driven by our own values and goals, or how we might be impeded in that effort. So in this context, I want to talk about two different things, and the line can be blurry between these two, but one of them is the ways that we might consciously, intentionally entrust AI to make decisions for us. So imagine if you're using Waze and you want to get from point A to point B, and it's going to give you 3 choices, and you can pick the one that's the most scenic, or the one that's the most efficient and quick, or the one that doesn't have highways. Maybe a fitness regime. You might ask an app to help you design a fitness regime and trust that it's going to do that. But there are other ways, though, that AI might affect our decision-making in ways that we don't as readily perceive. And for these, I wanted to bring attention to personalization, high degrees of personalization online, and the rabbit holes that you hear people talking about, like in YouTube or TikTok, if you use this app. And the ways that increasing reliance on algorithmically directed content, recommendation systems, perhaps combined with autoplay. If any of you during COVID, for example, have been watching Netflix and then boom, 5 seconds later, that next episode starts, and it's so hard to drag yourself away from the TV. And those things combined with other features like endless scroll, or user design features, choice architecture, dark patterns, all of these things combined have serious implications for autonomy. We can really only choose the paths that are made available to us. And it calls into question the extent to which the decisions that we're making online and in technologically mediated environments are really our own. And it raises important questions about the motivations of companies, and to what extent their interests that are driving these various designs might conflict with our own best interests. So Allison, I mean, we were talking before, but how do these algorithms actually use information about us to direct those decisions? How does it even work?
Right. So there are lots of different types of algorithms, and I'll focus just on recommendations. So you imagine going online, picking a video, picking a news article to read. And one of the key distinctions that people make in the recommendation system world is content-based filtering and collaborative filtering. So content-based filtering is when you go in and you're explicitly saying that you like soccer. You say, like, I like soccer, I want to watch soccer videos. And then the system can kind of give you content that's related to soccer, right? That's, a very rough approximation. But you have to go in and manually kind of assign these labels, like define your user profile. You think of Stitch Fix, right? You go into Stitch Fix and you express what are your style preferences. And then they use that as part of a machine learning algorithm to inform their stylists, make recommendations to their stylists that they then send to you, right? Then there's implicit data, where instead of going in YouTube and saying, I like soccer, you just happen to watch a soccer video. And so that's implicit data. And then what happens there is your patterns of behavior are compared against other patterns, like of different users that happen to watch that same video, perhaps. And if you liked, this one video and another video, and somebody else liked the same first video and a third video that you haven't watched, then maybe you're recommended that third video just because of that, collaborative infrastructure. And so the algorithm makes use of those patterns. But we don't always think about the kind of data we're providing. If we go in and rate a movie on Netflix, we're thinking this is data I'm providing to Netflix. But if we go in and watch a movie, we aren't necessarily thinking, oh, this is data that Netflix is going to use to make recommendations, but they do.
Well, I would tie that directly to how we view it in the privacy world, right? With the difference between what we call first party data and then inferences. And I think that a lot of people feel they have control when they go on Facebook and they say, I like this band, I like this movie, I like this, Etsy picture or whatever it is that people like on Facebook. But people have a little bit less understanding. I think your average consumer has less understanding about the second category you talked about, which we refer to as inferences, like inferences that are made from all that data. And how the inferences are just as relevant to the rabbit hole, to the next thing that you see down the road. And then within the information economy, I would also bring attention to the role played by data brokers. And there was a great hearing before the Senate Finance Committee today that involved a lot of information about data brokers for people who are interested. But data brokers, right, collect, compile, analyze, drawing inferences from information, profile, categorize, and sell personal data throughout our economy. And that is really working that inferential data in ways that people don't, I think, fully grasp the implications.
And one of the things that firms really need to be doing as they're collecting and using this implicit data is figuring out what are the metrics that they really care about, because what they're optimizing for leads to different products. So if you optimize for number of clicks, right, you have a system and you're just trying to find the, the recommendations that give the most clicks, guess what you're going to get is clickbait, right? If you have something that optimizes for watch time, you're going to get the rabbit hole of watch time where you just endlessly watch. So those metrics that firms are using to define what's good has a huge implication for how these systems work. The same system with a different metric can behave totally differently. So like my plug for firms is we need to be thinking about what are our values and how do we encode those values in a metric that we can then use to create a system that's consistent with our values.
Well, and I would follow that in terms of, what can we do about this situation for consumers, just being aware that the entities that are making the choices here, that are creating the design and the choice architecture, their interests aren't the same as yours as a consumer. So be aware, and that can help with autonomous decision making. But also we do have a bit of a market failure situation here with privacy, because we have no privacy regulation in the commercial space. We're operating with a notice and consent system, which basically allows companies to decide how they want to collect and use data and just tell you about it. Not a lot of opportunities to get yourself out of that scenario. So in my view, and a lot of folks in the privacy community, we really need a federal comprehensive privacy law that can provide some baseline protections for people's data and constrain the way that companies are able to use certain data, especially sensitive data, and inferences that are also sensitive in this context. So there's really a role for everyone to play, I think, in this scenario: consumers, businesses, government, policymakers.
I completely agree with that.
Allison, Jolynn, this has been fantastic. Thank you. You have triggered many questions from our audience already, which we'll get to when we get to the question and answer, but we're going to turn to our final duet now to talk with us about the implications in health and medicine. And so joining us for that conversation are Michael Pincina, who is a professor of biostatistics and bioinformatics and the vice dean for data science and information technology at the School of Medicine, as well as Michael Carey, who is an associate professor in the School of Nursing. No conversation about AI and capabilities and implications would be complete without focusing in this space and in this area of health and medicine. And so let me invite Michael and Michael to turn on your cameras and to turn on your microphones and to take it away for a conversation for the next few minutes before we turn to the Q&A. So Michael and Michael.
Thank you, Nita, for having us. As you say, health is different, or we believe health is somewhat different in terms of the applications of AI. I think Allison mentioned Stitch Fix, right? So that's the company that ships you boxes of clothing based on your preferences. And well, what are the costs, right? So you get a wrong shirt or a wrong pair of shoes or something that doesn't fit. And as a consumer, you will be annoyed and you may not buy it, or you may not look as you'd like when you attend the party. Contrast that with an algorithm that helps you decide people at the highest risk of sepsis in the hospital, or people who should receive statin to prevent cardiovascular disease, or women who need to get a genetically specified therapy for breast cancer. If you get that wrong, the failure has a higher cost, right? And I think in medicine, that comes very real. I will say personally, I'm very willing to accept a black box algorithm that's going to send me clothes, and I don't need to know how the algorithm works as long as the clothes work. An algorithm that will affect my health and potentially my life, I'm more worried. And Michael, you represent nursing, kind of the clinical front lines. How do you feel about, how do you view these things in kind of real clinical practice?
Yeah, I would say that, Michael, I think there's a significant amount of promise with AI in healthcare. Why? Because clinicians are hopeful that AI can transform the status quo in healthcare delivery and guide decision in terms of treatment and managing patients across the care continuum. And we've had a great deal of success in a range of applications, from aiding in the detection of diseases, such as detecting and diagnosing skin cancers in dermatology, or diabetic retinopathy in ophthalmology. And as you mentioned earlier about sepsis, one of the really promising AI applications that are actually been installed within our Duke healthcare system is Sepsis Watch. And I'm very proud of Sepsis Watch and its creators, because, for anyone that doesn't know, sepsis is when your body has this unusual and severe response to an infection, which can quickly lead to organ failure and death. And I think nationally, folks who are diagnosed with sepsis have about a 30% mortality rate, right? So, and it's very costly to the healthcare system. So it's clearly a problem with significant health and cost implications. And so Sepsis Watch is an early detection system that identifies who is at greatest risk, and it quickly alerts a nurse response team to enact a different, or I should say, a series of measures to monitor and reduce their risk. So I think there's a significant amount of promise in AI, but there's some challenges that we should consider too.
Right. And so I kind of go back to my years with the Framingham Heart Study, right, where we developed these Framingham functions and wanted to apply them everywhere, and I think made good progress in quantifying risk. And these functions, I'm a statistician, right, so they were reasonably simple. And right now people look at them and say, yeah, it's regression. We understand it. It still takes some math to be able to understand them. But then AI came, the advanced AI, the deep learning AI, convolutional neural networks, right? The more complicated mathematical algorithms, which are harder to understand, and some of them, it's even, people say, well, they are not meant to be understood on the level of explaining what does what that we're used to, but they work, right? So the kind of proof is in the pudding. But I will say in Framingham, the issue we grappled with was people were not using the algorithms. We're putting these functions, and they were published in nice papers, but they were not applied in clinic. And I will say, as you're saying, in our Duke Health system, we're doing quite well. I think the last tally I heard, we have over 50 algorithms running throughout, and it's a large number compared to other places. But still, the adoption and the trust is not what it needs to be, right? What does it take a clinician, a nurse, to really want to use an algorithm? Because it's not the fancy math, it's not the C statistic or whichever performance metric that we statisticians think about. What drives the use clinically?
So I would say there's a couple of things to consider, because everyone wants support in their job functions to make them easier, so that we can be more efficient in what we do. The challenge comes in whether or not it's integrated well within our clinical workflow, and whether or not that increases our technical and cognitive load factors, right? What I mean by that is, if I'm using an algorithm and it actually takes more time for me to understand it or to implement it in some way, then the likelihood of me adopting it is very low. So ways that we can improve in those areas of adoption is from the very beginning of developing these algorithms, we need patient and clinician engagement from the very beginning. And there are stakeholder groups that we can create as a part of that process to kind of co-design these algorithms so that they are something that we can implement within the clinical workflow of these individuals, something that is highly interpretable by these individuals and actionable. So those are some of the things that I think would help kind of improve adoption and uptake of these algorithms.
Right. No, I think that's a very important point. I think another successful algorithm we implemented in Duke Health is the one that predicts hospitalizations, right? And that was, we tried a number of external algorithms, and it was actually the nursing staff that didn't want to touch it and say that doesn't feel right or doesn't resonate with their practice. And so we embarked on developing our own algorithm involving the clinical experts who are using them in everyday practice. And I think that was embraced much more rapidly and much more happily. And so I totally agree with you, right? It's I develop algorithms for the simpler ones, but the promise is amazing. But as you say, the implementation, having the end user in mind is critical. It's not the fancy math that's going to make it or break it for us. And then what about pitfalls? What about bias, right? We hear stories like the algorithm described in Science, which basically used the wrong proxy. Instead of going for the true healthcare need, they went for healthcare utilization, which is lower among Black patients, and that created huge bias, right? The numbers were enormous. I think 50% needed healthcare resources and special attention, and the algorithm showed it was below 20%. So it's enormous amount. How do we avoid that? Because I think if we are not careful, that will derail the entire promise of the field.
It sure will, Michael. I mean, one of the things I think about when we talk about bias is, so there's been a lot of work that's been done to detect bias, and I think should be, or not as much work that's been done to mitigate the bias. So there's different strategies. When I think about bias, there's different strategies that we could consider along the developmental process of these algorithms, right? And from the very beginning, when we think about, there's this old computer adage, garbage in, garbage out. And so if we don't have the right data, and if the data is not representative of the population of a whole, then the outputs are not going to be accurate, right? So if we're training a data set and it predominantly has a white or Caucasian population, it may not perform or underperform in minority groups. And so how effective is it for our healthcare system if it only impacts one group and it disadvantages another, right? So I think one of the things that we would like to do is strive to create these comprehensive and large, diverse data sets. Another thing I think that we can do and consider is evaluating these data sets in these algorithms to make sure that they're performing across these groups optimally. And then another thing I would consider is when we deploy or the implementation of these algorithms. Bias can occur in situations where the patient cohort in practice differs from the patient cohort in which we train the data set on. And so that's called the domain shift. It reduces the algorithm's performance. And one of the things that you might see is that happening is if it works great in Duke, if we implemented it at UCSF in a medical center there, the different geography between these two areas, the patient populations could result in different performance between these two algorithms. So there's lots of things to consider in terms of bias that we should kind of think about throughout the entire developmental cycle of these algorithms.
Right. No, those are really important points. Again, my Framingham experience coming back, right? Largely Caucasian population in a small town in Massachusetts, it did well, but again, we took it to the limits. Unfortunately, we have much more data right now, but as you're saying, the data is potentially wrought with biases, right? And if we're not aware of them, it's kind of the size of the data. Like some people in the AI field believe that the size of the data can compensate for the quality, and I'm not so sure, right? I think we need to really understand the data better. I want to ask you another thing. So I was talking to a colleague about fighting bias, right, and eliminating bias, and I think her point was that we need to start with transparency. So that's where we started this discussion. Would you agree with that? That transparency is the necessary first step to really start looking at these algorithms in healthcare more carefully?
So I would say transparency is extremely important, Michael. But I would start by making the assumption that most of these algorithms you can assume that they have a certain degree of bias in them, right? Because they are created by human beings. Your upbringing, your experiences, your culture shapes what you do, and we internalize certain assumptions around the world around us. And so, these things don't happen in a vacuum, but they are developed by people. So I think starting off by saying there is a certain degree of bias that we should think about, look for, detect, and mitigate is a great way to kind of think about bias mitigation. The other thing is, to your point, transparency is important.
Let me hold you on the other thing, Michael,
sorry.
because we have questions that are going to be addressing that
Sorry.
very issue. And so let me invite us to have that conversation on the second point as we go to the Q&A. Let me invite all of our panelists to turn their videos back on so that we have some time for Q&A now. Thanks to Michael and Michael for that important conversation about health and data and thinking about issues with respect to bias and data sets, which I think brings us all the way back around to the beginning as we tie together these issues with respect to data and potential implications of data. And so I thought I would circle back around to Jonathan. As you listen, Jonathan, to the conversation between Michael and Michael, and you think about the risk in the national security setting of bias and data and kind of the issues that arise in that setting, what are some of the reactions you have and some of the thoughts you have as to what the solutions are in high stakes settings like national security? Is bias mitigation sufficient? Who's responsible for ensuring the quality of the data to safeguard us in such high stakes situations?
Thanks, Nita. Yeah, so for me, the biggest thing is actually the engagement between the communities. In other words, we need to have people that understand AI actually being in the US government, and we need to be having conversations the other way. I mean, I think Jeff and I are both great examples, right? We spent multiple years serving within the US government to be part of that. And I would just, recommend to anyone that has the opportunity to do that or engage, across the lines between academia and government. That's kind of the most important thing we need to do, is just training each other on what the implications are, because that's the only way we're going to solve the problem.
Yeah, and I think that helps everybody realize that everybody has a part to play, right? It's not just a simple question of who ought to be governing it and who's responsible for it, but it's something that we all can play a part in, which I think ties into some of the messages that Jolynn was speaking about with respect to, one solution, of course, is to turn to comprehensive privacy legislation as, the kind of answer to some of the risks and benefits that AI introduces. Another is to look at what individuals can do and what they ought to be doing. And I know you and I have had some interesting conversations about, you keep everything in your head. You don't put anything in technology. You're much more, I think, suspect of technology, but also much more proactive in safeguarding yourself against the risks that are introduced. And so I was wondering if you could speak to that as you think about questions of this panel, responsibility and liability. You mentioned one, which is government legislation, but who else bears responsibility, and how else can people take proactive roles to address the challenges that are introduced by AI?
It's a great question. And while I do think that we as individuals can make some choices, like using Signal for texting or Proton Mail for mail or DuckDuckGo for a search engine, there's really, this problem can be solved by consumers alone. And in fact, we're talking in the Debugger podcast with Bob Sullivan about the original sin of the internet. And I think, this whole self-regulatory approach and putting the onus, frankly, on consumers to protect their own data is a little bit crazy town. I mean, it's just not a good approach. It doesn't scale. It's not working. And that's why we need the legislation. But in the meantime, I completely agree with Jonathan's point about people who understand AI being in government. And I would extend that to, there's some great new hires in the FTC who focus on AI. You have people like Ed Felton and Ashkan Soltani, who have been chief technologists at the FTC, and we desperately need that technology and engineering expertise there. I would say also with comp sci and engineering folks, we need to think about the actual design and implementation of technologies. And one of the questions in the chat went to this. I do think there's responsibility. You design something, you just don't unleash it on the world and move on to plan B. Right? I mean, if you put something out there, I think you do have some responsibility for how that's used in the world. And I'd like to see more companies and startups, making a difference there. And then the final thing is in a policy perspective, when there's not a law that's making you do something, stand up and really ask what is right in this situation. Bring some ethical analyses to the question and think about all your stakeholders and not just the bottom line. Growth and engagement.
That question of what is right is a challenging one, right? Especially in this particular space. And I could turn to any one of you and asking you what you think is right, but there's a question from the chat that I want to raise that issue for Jeff, which is in the chat, one of the questions that one of our audience members posed was, when you look at issues like autonomous decision-making from AI versus human intervention, that this choice can be a zero-sum game, that autonomous AI can introduce faster and potentially more accurate decisions, but humans can bring much more nuanced analysis and also be guided by moral decisions in a way that AI may not be. And so as you try to think about that in the national security setting or, in other areas of your work, how do you balance that, the competing interests between, the speed and potential accuracy versus the more nuanced analysis and moral decision-making that humans can bring to bear?
Yeah, I think, so the aspiration, I think the current model, at least when I was at DARPA, wasn't that long ago, was the thought that the humans would invoke the strategy and policy, and the machine would help with the, shall we say, the more tactical operational involvement. And I think they found, of course, this is aspirational. That's the question. How do you do it, right? But they found they had various scenarios where they found that a machine, that kind of teaming arrangement really outperformed. Actually, one of the programs that I was not involved in, but happened after that, was a I can't remember the name immediately, but something that was having fighter pilots have AI assisted techniques to in other words, a fighter pilot has to control the plane and as well as figure out the tactics to do what they need to do to shoot down some. Well, they had a game that was designed for this, and they found out that the machines were actually outperforming the fighter pilots, period. And this was a big problem for the fighter pilots. So that's a case where speed is of critical importance. So it's that aspirational notion of, well, we're just going to do the strategy and then the machine is going to be our assistant, may backfire when it's actually implemented.
Yeah, I think that's right. And it brings me back to what Michael Carey was talking about with respect to bias. A lot of times when it comes to artificial intelligence, people have the misconception that if a machine is involved, there is no bias. and that only when humans are making the decisions is there risk of bias. But that kind of misconception and over reliance or over subscription to the beliefs of the accuracy and fairness of AI can be problematic. And Michael, you were going to talk about some of the issues with respect to bias, and particularly in the healthcare setting, bias data sets, and what implications that has both for how we ought to think about AI, but also what we can do to be able to combat it if we're going to be using it and relying on it in such high stakes decisions. I wonder if you could talk a bit about that.
Nita, you have to specify Michael Carey or Michael Pincina.
I thought I said Michael Carey, but Michael Carey
sorry.
is who I meant. I'm sorry.
Yeah, I think one of the things that Michael mentioned earlier that I don't think I answered the question as quickly as I should have, was he talked about transparency. And so transparency in how these algorithms are developed, transparency in how they should be interpreted. Those are the types of things that I think can increase the trust of the user, but also increase the trust of the patients. So those are the things I would consider when trying to mitigate bias and increasing trust and transparency.
And I just want to press you on that for a moment more, Michael Carey, which is, with respect to trust and thinking about it within the healthcare setting. One thing, that Jeffrey just mentioned was the, distinction potentially, or the kind of best practice scenario, the hope that, humans would be decision makers and AI would provide data. But how do we have that when we don't have transparency, right? So if you have, for example, a physician who's being asked to make a decision based on analysis or data from AI that isn't entirely transparent for how those recommendations or specifications about a radiographic image or something like that is made, what are the best practices for a physician in that position to be able to use AI effectively?
Yeah, I'll answer it this way. I would say that's where new processes need to be developed in creating what I think AI Health under Michael's leadership is involved in creating what we call equitable AI. And it gets at the importance of creating ethical principles, as well as ensuring that there are equitable outcomes among our patients. And maybe Michael can speak more to some of the work that they're doing in that particular effort.
Well, you gave me a softball there, Michael, because that's where I was going next, which was to Michael Pincina to be able to talk about these issues of equity and decision making. And one of the questions that we had, and while this is a more general question for all AI about what kinds of ethical principles may be out there, and there are many ethical principles that have been recommended in different aspects of AI, I hope you could speak to, in this particular context, what kinds of efforts you put into place and are underway for ethical AI with respect to equity and decision making and in healthcare.
Right. No, thank you. It's what we're doing with Duke AI Health. I think it's different a little bit nationally. We're part of the coalition of different AI in medicine health institutes, and we're very focused on evaluation, right, with an eye on ethical and equitable principles. Everybody runs to the design, new models, new algorithms, new math, flashy things, and I've done math for quite some time, and it's beautiful, but it's not enough, right? So I believe there needs to be really an amalgamation or connection between mathematics, engineering, statistics, the quantitative fields, and the social fields with ethics, sociology, right, and many others to really bring it together, because otherwise it's as we were saying, technology itself is not enough. Technology is a tool, but it's a tool that needs to serve humans. So what we're doing, we established an algorithm evaluation function in Duke Health System, right? Our chancellor made a commitment that no new algorithm will be applied to Duke patients unless it goes through a thorough review of the committee that we put together. And now we just put a call for the first AI health equity scholar. We want to bring an expert in health equity, not in data science, somebody interested in data science, who will help us advise, right, and lead us in making sure that we don't miss the boat in the evaluation process. And we want to grow that. We want to create think tanks and collaborations and having these discussions really to build the bridges, bring the different areas, sciences and others, right, to have the conversations and help establish these principles. There are publications on it, but they are scattered. And I think Ziad Obermeyer, who uncovered the bias of the algorithm that was applied to a number of health systems in the Northeast. He has a playbook that starts to outline, right, what we need to do to avoid bias. So we need sources and resources like that, but not only postulate them, but bring them and apply them into the algorithms that are in the current use of the health system. So a lot of work. Fortunately, the awareness is increasing. So I'm cautiously optimistic that we can get there.
Great, thanks, Michael. And you just said something that makes me want Allison to help close us out here, which is you said, technology is a tool that needs to serve humans. And one of the questions in the chats and Allison's work itself really is focused on this issue is, how can algorithms best serve humans? And a question that somebody asked you to which you responded with an interesting citation that I hope you could expand upon is, to what extent are these really aiding us in making our best decisions for ourselves versus manipulating us, coercing us to make choices that are contrary to our interest or what we would actually make? And so I was hoping you could end our discussion today with a comment and discussion of that issue.
Yeah, for sure. I think it really depends on the context. I think there are lots of situations in which we already have so many different sources for finding content. So if you're looking for a movie, you don't usually exclusively go to Netflix and only find your movies through Netflix. You have Amazon Prime and other services. You Google best movies of the year, or you go to Rotten Tomatoes. And so the Netflix algorithm is actually going to influence you a little bit less than you might think it does, because you have so many other sources to draw on. Now, collectively, you might see lots of different sources influencing you in kind of one direction. But I think we're pretty robust on our own decision making when we have lots of different resources. I think the biggest challenges are when are these more high risk scenarios, when we're talking about bail or healthcare or defense, right? Where it's not a consumer going on and able to look at the top 10 products for a different a given category. It's you have one system and one user making a choice based on the 5-10 recommendations that are provided. I think that's the highest risk. So as consumers, I think we're pretty robust. We're pretty well trained to use a variety of sources. But when it comes to the first category that Jolene talked about, where it's decisions made about us rather than by us, that's where the highest risk is. And I think that's where regulation especially can help.
Thanks everybody for the wonderful comments and conversation. I'm going to turn it over to Jen to close us out for the day with a big thanks and silent round of applause for all of our panelists.
Yeah, that is the challenge when we do these online sessions, is we don't have the opportunity to applaud at the end of the session. But I did want to say thank you to our wonderful discussion here. This has just been amazing. I learned a lot. I hope everybody on the call did as well. I also love that we brought in people from across the university. A lot of times these folks don't have the opportunity to work together. So here's a chance for us to learn from one another as well. This is the last session in our AI section for this semester. We have the other conversations already uploaded to the YouTube channel. This one will be uploaded later this week. As somebody mentioned, it'd be great to sort of continue the conversation. So I invite you to do that in that YouTube channel and add your comments there. We will also share some of the resources that were posted into the chat with you in this follow-up email as well. We have one more session for this month that is on the topic of wicked problems that looks at building thriving communities. We'll be looking at things like homelessness and refugee resettlement, food security in our communities. So if you would like to join us for that conversation, that's next Wednesday, also at 3 p.m. And we would love to see you there. For everybody again on this call, thank you so much for joining us this afternoon. And with that, I hope you have a great rest of the day.